Hi and welcome to Geeks for Geeks. Today we would be discussing the problem minimum steps to reach the destination. Here in this problem you are given a grid which consists of, or let's say for example, it consists of all these values and the values can be positive, negative or 0 to. Now, what is the objective? So this is the matrix and it can have these values. What needs to be done? What needs to be done is top left, bottom right. Okay. You need to start from top left and end at bottom right. And the way to move is to go on the right hand side. That is, if the coordinate here is x and y, it would be the column would increase because we are going on that side. That would be x plus y minus x plus 1 comma y. And if the next allowed option is to go down, that is, the row would remain, the column would remain the same and the row would increase. Okay, these are the two allowed options in which you can move. But there is one more constraint that you need to respect. This is the way I can move and respecting one constraint. What is that? To visualize this constraint, you can think of a Mario game or any of the basic games that you have played in your childhood. What really happens? Okay, like I would take the example of a Mario game. So initially the Mario has some health. If he is hit with a hindrance, he loses his health. Okay, and if he hits a good good position or something, he gains some health. Look, for visualization, for those who can't really visualize, I would help him visualize. Let's say this is the Mario. So let's say he jumps in here, so he would lose some health. But if he jumps here, he would gain some health. Okay, so in the same manner, if I take a jump on -3, I would have a lose of health of 3. If I take a jump of 3, I would have an health of more than 3. So just as the regular game goes, here also your health should always be positive. So I would just take the example of health and move forward. Health should always be positive. Now, so if the health needs to be positive, I need, so you need to tell him what is the minimum health I should have so that I can finish off. Minimum health, what do I mean? Let's say I have an health of 100. So I came here, I now have a health of 98 because I lost an health. I came here, I lost an health, that is 95. I came here and I lost an health, I added an health, that is 98. And then I came here, I gained an health, that is 99. I came here and I had an health of 94 in the end, and at no point, if you observe, I had a negative or a 0 health. Okay, this is how I can move from top left to bottom right. But if you observe, the 94 or the 100 health was not required that much, so you need to report the minimum health. Here in this problem, for example, let's say I have an health of 6. I came here, I lost some health, that is 2, and it became 4. I came here, lost some health, that is 3, and it became 1. And I came here, gained some health, that it is becoming 4. I came here, it became 5. Then I came here, so it became 0. So at this point, it is not a valid thing because at once this health became 0. Health should always be positive. So now let's try the same thing with health is equals to 7. I came here, now I lost some health of 2, that is 5. I came here, I lost an health of 3, that would become 2. I came here, gained an health of 3, that would make it 5. I came here, gained an health of 6. And then I came here, I lost an health of 5, that would make it 1. Now if you observe that our health was positive throughout the end, and this is the minimum possible answer, that is why the initial health that is required for this problem is 7, not less than that, and more than that is always possible. Okay, so if you see the problem in the very first glance, it would seem that yes, this can be done. Like, it gives us an idea of monotonic function. But people who don't really know advanced binary search, they won't get the idea of monotonic function. And that is kind of out of the scope of this. But the problem is to choose the optimal path also. Like, if a predefined path was there, then we could have easily tracked down what is the health required. But we have many paths here. Like, we can go from here to here, we can go from here to here, and then we can also take up this path. Same goes for this, we can take up this path. So there are many possible paths. We need to take the optimal path and then give the optimal minimum health. Like, what we really need to do is we need to find the cheapest path and then report the minimum health that is required. Okay, now the very first easy thing that would come in your mind is that I would always try to jump on a positive value, and I would try to avoid negative values. But this is a greedy approach, and that won't really give you the answer. You can try it on your end, but I would just give you the intuition why this won't work. Else this video would be a little bit too lengthy, of course. So the idea is, let's say I'm standing here, and here I have a value of 1. Here I have a value of, let's say, -1. So if I am at here, I would try to go on the right hand side because I thought that yes, positive values would always be beneficial. But the problem would arise when ahead of positive value you have no option but -100 and -100 here itself. So you have no option. Like, from, if you take this path that is 1, then I have no option to move. I can only move to right hand side or bottom, but I need to hit -100 health. And contrary to this, I can have, like, if I take this path, this is much more cheap to me. Like, if I take up this path, see here, if I try to prioritize the positive or the 0 value rather than negative values, what would happen? So here from, I have two options to go on this side or this side. So I would go on this side because positive value looks beneficial to me. Now I have no option. Both the values are negative and both the values are of the same magnitude. Let's say I took up this value. So now I took up this value. From here I have no option but to rather go down because I can't move on the right hand side. So now I have from here, I am seeing this from here I can also move down only. So I need an initial health of very much, like, I need an initial health of around 95 or 97, 98. But contrary to this, if I take up this path, this path is very much cheap. I would only require a health of 2 to finish off this path. So just walking over the positive values rather than negative values won't solve. And what is the intuition to this? Intuition to this is, yes, it might be the scenario that for the time being the positive value is looking good, but after positive value there might be a big negative value that is standing in ahead of it. Taking a good example of this would be like, this is a very, like I would say, a very common approach in seeing if DP would work or not. So I would try to give you a proper intuition of this. So the intuition or the example of this would be, let's say this is me, Siddharth. Okay. There are some things which gives us temporary pleasures. Like let's say as of now, playing games during my board examination seems good to me. But studying seems bad to me. But if I just play games, then ahead of playing games, I might ruin my board examination results. If that is my goal. If your goal is to become esports player or something, and that's different. I'm just talking about a general scenario where you want, like your goal is to become good in board examination. I respect other professions, of course. So if I play games at the moment of board examination, I would ruin my board examination results. And if I study, which seems hard in the current situation, might give me a shining result, a good result. So, if I so this is the scenario that at the point of a teenage, I can't really decide, do I need to play games or do I need to study? Okay, so I need to try both possible options, which would give me good results. In the same manner, here I can't really decide to go towards the positive side or negative side. बिकॉज अभी के लिए अगर मैंने पॉजिटिव ले भी लिया तो आगे जाके वो बड़ा कोई नेगेटिव आ गया और मैं मूव नहीं कर सकता इधर उधर, तो वो खराब आंसर दे देगा. डजंट गारंटी यू अ गुड आंसर. सो व्हेन यू ट्राई अ ग्रीडी अप्रोच and it is failing and it fails for certain test cases or ideas, then the idea is to try all possible ways. To try all possible ways. What I meant is, अगर मैं greedy is what? Greedy is a predefined path. If I can't go on the predefined path and get the desired result, then I need to explore all possible paths to get the desired result. Like out of them, which would give me the desired result. Like I don't know how many of you have read the story of Robert Frost, that path not taken. Not story, it's a poem, of course. So what happens is, like I'm lost in the woods and there are two different paths ahead of me. One seems like less taken and one seems that yes, it has been used by the local people. So now I can't really decide, so I need to go on both of the path. So the same manner, if I can't really decide in which predefined manner I would go and I would get the desired result, I need to try all possible ways. Now whenever in data structures and algorithms or competitive programming or in the era of data or in the era of DSA, whenever we come to this conclusion, I would say that this can be solved using recursion. Recursion is nothing but trying all possible ways. Okay, so now let's try to think of a recursive code to solve up this problem. Okay, now I observed the editorials and other ways, and they followed a tabulation method, bottom up and other approaches. But here I would go with the very basic recursion and then memorize it. Okay, so in the editorial we have a bottom up approach, but here I would just go a top down approach. Okay, and it seems easy to me. It's a personal preference. The time complexity would remain the same for both of them. Okay, now let us start solving this. So see, I would start with the very first top left corner. and I would go to the bottom of m minus 1 comma n minus 1. Okay, so this is my starting point. Okay, so let's talk about the base case first. What is the base case? Always remember, the base case is the very basic or the very small case that you can solve by yourself. So here, what would be the very small case? The very small case would be when the matrix contains of just one element, that it is 1 cross n, 1 cross 1 matrix. Okay, and this would kind of draw you the solution every time. I do this, like I have done this for the last 4 years and it is working perfectly fine for me. So I came here and I saw a 5 value over here. So if I want to visit this and this is 5, then I don't need any value. Like I can directly come up and visit this. I don't need any predefined health or something. So I can simply say that for the base case, if it is a positive value, then I would require only a health of 1. Okay, because I can't have 0, like I can't have non-positive health. Like the health can never be 0 or negative. That is why even if the value is positive, I need a health of 1. But let's say the health is negative, like the health is minus 5. If the health is minus 5, I would require plus 6 health. The minimum health required would be plus 6. So that 6 minus 5, I would still have 1 health in my hand, and this is the minimum answer. So if it is a negative value or a 0 value, like I can simply sum up this, that it is not equal to a positive value, then the answer would be nothing but 1 plus the absolute value of whatever is kept here. Okay, thought about the base case? The base case is the very small case, smallest case that can be handled by you. So done with the base case. When the base case is done, like what is recursion basically? Recursion is made up of 2 things only, recursive step and base case. So now let us try to sum up the recursive step. So recursive step, okay, so we have it here. Let's say this is a big grid or a 2D matrix, whatever you say. So let's say I'm standing here. Let's say I'm standing here. And it is telling me that here I would get 2 values. In the recursive step, I would call for 2 values. Like I would go in from a particular, if I am at a position x and y, what are the probable options I have? I have options to go on x plus 1 comma y. I have probable option to go to x plus y plus x comma y plus 1. So I have the probable option to go on both of the sides. So I would try both of the sides because this is a recursion. So let's say this recursion friend of mine, I tried that way and it gave me a value that he told me, see, if you go on the right hand side, a value of 5 is required. A value of 5 is required. Let's say this person, like recursion returned me that if you go from the right hand side, a value of 5 is required. So if a positive value is required, then I can simply say that, like if positive value is required, like let's say here I have 10 and I called for the right hand side, and it told me that the positive value is required, and that is positive value of 5 is required. So if I have the bandwidth, then it is okay. If I don't have the bandwidth, why? Let's say I have something like 1, and he told me a 5 health is required to go from the right hand side, because the recursion would do everything on its own. You just need to think in the middle. Like I would call for the right, and it told me 5 health is required, but here I have only 1. So how much more health is required? How much more health is required here? If currently I have 1 health and he is asking me 5, so how much more health is required? And he tells me, say if you go on that side, 5 more health is required. So I would say whatever that value is returning on the right hand side, that is whatever that value is returned from the right hand side minus the current value, that is the current health. Okay. Now whatever value is required, and same goes for this side also, x comma y plus 1. So now let's say I am standing at x and y. I asked that if I go on the right hand side, how many points are required? He told me a points are required to go from the right hand side. Okay. I told him how many points are required to go from the bottom, that is b. So just let us understand for a only, that is for right hand side, and same would go for the bottom also. Like same thing would happen for bottom also. So let's say I asked that if I go from the right hand side, what is the health required? He told me a health is required if I go from the right hand side, that is x plus 1 comma y. If I start from x plus 1 comma y. So currently I have a health of something. So I would say whatever the value you have minus the current, that is the value of what is current? Current is this one, the current value. Okay. If that value, I would explain it, just take it as a Jagran. If this value is equals to V, and if this value is greater than 0, then take this value, accept. If this value is less than 0, then make it 1. How do you say this, Siddharth? The value which came from the right minus the current value, if it is greater than 0, I would accept it as it is. If it is less than 1, I would take it as 1. How do you say this? See, this cunning implementation would make go away many if statements. Like if we do it explicitly, it would, like we need to do it explicitly like we saw earlier. Like if let's say there is negative or something, we need to do a lot of handling. But these two statements does a lot of handling themselves. So let's say the right demands me a health of 5, and I currently from this cell I have a health of 6. So required health is more than what I need. So I would simply accept it, because so if I just ask him, see, let's say I want to go on that road. Okay, let's say I'm low on fuel. What I meant is, let's say I'm low on fuel. I'm driving a bike at this point and I'm low on fuel. So I ask another person, how many kilometers are there in reaching Delhi? He would say 100 kilometers. I see my bike and I see that yes, it can go 100 kilometers. So I would simply move forward. So someone came and told me that if you go on the right hand side, a value of 10 is required, but currently I have a health of 4. So how much more health is required? 6. So 10 minus 4 would give me the correct health that is required. Correct health that is required. See, he told like if they told me that if you go from the right hand side, 10 health is required, but I have only 4. So that is why I did just this. 10 minus 4, it is 6, and yes, that is why I simply accept if it is a positive result. Let's say other way around. If let's say I already have, like, I have a health of 10 and the required health is 5. So if I have more than what was there, so if you observe, this is a positive value. So if the required health is 5 and I already have 10, then I need no more health, just a value 1, so that I don't have a 0 value. So that is why I cunningly just subtracted the current value from the right hand side. So now this we would do the same thing for x comma y plus 1. फिर से बता देता हूँ. ट्रांसलेटिंग द सेम इन हिंदी वुड बी, देखो, जब भी राइट से जाने के लिए ज़्यादा हेल्थ चाहिए, तो सी, if this value is more, what I meant is this value is more and this value is less, then only this would become positive. So moving on the right hand side requires more health and I have comparatively less health. So the difference amount would be the health needed. That is why I would accept it. But if the value, that is A, is less and current is more, if I have more than what is required, I would simply take 1 as the answer. So I would write the same thing here. So recursive step is this. Now let us write int recursion, and here I would simply have x and y itself. As of now, let us just have x and y so that we don't get confused. Okay, fair enough. We would first write the base case. What was the base case? If x is equals to m minus 1 and y is equals to n minus 1, if there is only one box. So if there is only one box, we would first check if a of x and y, if it is a positive value, then I don't need anything else but just one, positive 1. Else, if it is a 0 or a negative value, then I would simply return abs of a of x and y and add 1 to it, because I need one more health so that my health doesn't become 0. Okay. Now moving forward, here I would say answer. Here I would just move on the right hand side. So right hand side is equals to rec of x plus 1 comma y. Okay. The left hand side, the bottom, is equals to rec of x comma y plus 1, and answer is equals to, okay, so answer is equals to min of right or bottom, whatever the value came from, subtract the value of current. That is, what was current? Current was the value that is kept on x and y. So a of x and y. Okay. Now I would say if answer is greater than 0, then do nothing. But if the answer is less than 0, okay, if the answer is less than or equal to 0, I would simply say answer is equals to 1. Okay. Now I would return the value of answer. Now, of course, we don't have the reference to n, m, and points. So we need the reference of them. So now I would add the additional parameters which are dynamic and won't change. So this was the implementation. You don't get confused. That is why I did this. So now I would just add up the additional parameters and make this as a, because I'm very lazy enough. And we need to pass them again, m comma n comma a, and same goes for m comma n comma a, and we would return that. So now return rec of 0 comma 0, that is we would start working from the top left. Now let us just compile and see how many errors are we making. So this is not working because we did miss one thing. What is that? This is because, let's say I am standing at this index, like I forgot to tell you this. I'm standing at this index and I am trying to go on this side, which does not exist. So if anyhow I move an value, I move an index which is outside something, I would return a very big value which won't contribute to this minimum. Okay. So what I can say is that if x is more than equal to m, or y is more than equal to n, then return a very big value like int max. Okay, now let us compile and again see. Yep, this is working. But if we submit this, we would get a time limit exceeded. Okay, this is because we are doing repetitive work in recursion. You can draw out the recursion tree like that. Don't draw for discussion, it would be a little bit complex. Like if you want to understand the inner workings, why this does the repetitive work, draw the recursion tree of Fibonacci series and you would observe that a lot of repetitive calls are being made. So we now need to memorize it. So whenever we want to memorize it, you don't really need to categorize this into 1D or 2D or 3D DP playlist or something. What you really need to do is just see what is the number of variables that are dynamic here. The variables that are changing here is x and y. Everything is just an information that is kept and retrieved when required, and the informations are not changing. These, like m, n, and the array a is not changing, only x and y is changing. Now what is the lowest value of x that would exist? The lowest value of x that would exist is 0, because we are starting off from it. And like if we talk about x, and if it is greater or equal to m, like this is m minus 1, this is m or m plus 1 from here this side. So see, till this point x would be there, but if we hit m or more than the value of m, this would be handled by the base case. So you need to cater the things which is not handled by the base case but would come into this recursion function, which is 0, like the lowest value is 0 and the highest value is m minus 1 for x. Do the same thing for y on your end and then verify if you're doing this. Y would be the same. Y can either be 0 or the maximum value would be n minus 1. After, if it is n or greater than n, it would be handled by the base case. So just have the lowest or the highest values. So now we can see that we have the lowest value of x as 0 to m minus 1. and the highest value of y as 0 to n minus 1. So see, we can just hash up this in a 2D array. The number of variables which are dynamic would be the dimension of the array that is required. It doesn't really needs to be categorized 2D or 3D DP. Okay, so now what I would do is I would simply make a 2D array, okay, named as DP with the size as m, so that the index 0 to m minus 1 would be present, and the vector int of size what? Of size n with all the initial values as -1. So that no, like we are just implementing a caching over here. -1 just tells me that no value is present, and we would take that caching with him. Now here I need to just have the same thing again, but this time the name would be DP. Now just after the base case, write the statement: if dp of x dash y is not equal to -1, that if the value is like -1 indicates what? The value is not cached. And if the value is not -1, it indicates that the value is cached. So if the value is cached, return the cached value, that is x and y. This is just like I remember, like I did something, I remember it. So next time when I'm going to do the same work again, I don't really need to do it again. And then like let's take a funny example. Let's say this is me. I made like I made a friendship with a girl named as, let's say, Shreya. Okay, and I found out that her traits doesn't match with me. Okay, so I wrote it down that yes, Shreya's trait doesn't match with me, and after building up the friendship. Now let's say after many years I forgot about Shreya's trait, and next time I again made a friendship with her, and then I found out that Shreya's traits doesn't match with me. So I need to remember and write it somewhere. So the next time I make friendship with a girl named as Shreya, I already see it if she is of my traits or not. So in the same manner, we would just see if I already know that the traits doesn't match, so I won't go and build a friendship. Okay, I would just directly return the result. If I am building out the friendship and doing this much of hard work, then I would write it down in my diary. So dp of x and y, here I would just save the answer. Okay, now here in the parameters, one extra parameters of dp would be added. So you now see how like this code now looks a bit complex, but breaking down from recursion to this point. Now let us just try to submit this and see if we can get an AC or not. So I need to pass this by reference. A copy of this is not saved. So now this should solve. Yes. So a pass by reference because a copy was made again and again and we were losing the values. So I took a lot of effort, like a very big lengthy video, and I took everything slowly because this is a very fundamental problem of dynamic programming. As well as from this problem I tried to teach you dynamic programming just from the base of recursion. So if you think that yes, this hard work needs to be justified and appreciated so that I would be motivated enough to make more beginner friendly videos of hard level problems, so that the amount of takeaway would be very much more, rather than just spitting out that this is a prerequisite, please learn this and then come back to this problem. So I want to know if the audience are comfortable enough with long videos where the takeaway is more, or short videos where you just want to know the crux of the solution. So be the person, like you all should decide which kind of videos, and based on the feedback of the comments, I would move forward and make further videos of those kind. That's it for today. Kindly tell me your views on this. And the time complexity is that we are filling each value exactly once, and we are filling m multiplied by n value. So this time complexity is m multiplied by n, and we are using an auxiliary array of m cross n. So the space complexity is also big O of m cross n. That's it for today. Thank you and have a nice day.